All right. I think we might kick off if that's okay. Just to let everyone know, we are recording this session, so it will be made available tomorrow. We'll get it up online tomorrow for you. So again, I'll just run through a little bit of housekeeping. So obviously, if you're here, you probably already know that I'm chatting with Jenny Bailey, our general manager of projects, Capricorn Power. So we're just going to have a bit of just a chat, honestly. She and I will talk about bioenergy and the circular economy. And then we will have a Q&A afterwards. So you can either type in the chat or the Q&A, and we'll try to get to as many questions as possible at the end of the presentation. And before we kick things off, I do want to have an acknowledgement of country. I would like to acknowledge that this meeting is being held on the traditional lands of the Wurundjeri people of the Kulin Nation, and pay my respect to elders, both past, present, and future. And so we might kick off. I just mentioned that today we have Jenny Bailey. Hi, Jenny. How are you?
Hi, Sujanya. Thanks for having me.
Yeah, of course. So as I mentioned, today's topic is bioenergy and the circular economy. And really we want to talk about why, Capricorn Power, why we're so interested in it, why we're so interested in it, why we're so invested in it with our initial project. And before we get into the conversation, I actually thought it would be good to show you an animated video explainer, which you might have seen if you've gone to our website or our social media, but I think it's a pretty good entree into this conversation. So just bear with me when I prep this video. Well, this just takes 1 second on Zoom.
At Capricorn Power, we've developed a technology that reduces waste and emissions and produces sustainable energy. Billions of tons of organic waste is produced each year in local communities, including from normal farming practices. Much of this green waste is destined for landfill, where it rots and produces methane, which has 25 times the greenhouse impact of carbon dioxide. Our hassle-free solution takes this biomass and generates electricity 24 hours a day, 7 days a week, all while replenishing our earth with much-needed nutrients and helping to feed our livestock. 1. First, we divert a problematic biomass waste stream like green waste, food waste, or crop residue from going to landfill. 2. The waste goes through pyrolysis, a process of chemically decomposing organic materials at high temperatures in the absence of oxygen. 3. This process creates biochar, an important resource which is used in a variety of applications, including purifying drinking water, enriching soil, and adding nutrients to livestock feed. 4. Finally, the heat generated from this process, which would normally be wasted, then moves through our compact patent-pending Barton heat engine. The engine is a flexible solution for many applications, as its footprint is only the size of a small container, and it's proudly manufactured in Australia. Without using any water or creating harmful emissions, we're able to generate up to 3 times the electricity from the same heat source compared to today's alternative heat engines. At Capricorn Power, we're looking to save our customers money without risk or hassle, while helping the environment. We can build a brighter future together with a heat engine in every community.
Thanks for that. Hopefully everyone enjoyed that if you haven't seen it before. So might as well kick off with my first question for Jenny. So obviously we make heat engines at Capricorn Power that produce electricity from waste heat. So, just learning that's why I was so excited to work with Capricorn when I first started. And, I've learned now that we have a tremendous opportunity in different so many applications for the heat engine. So can you actually walk us through why we're so interested in bioenergy specifically? And I think it would be really useful for the audience to explain a bit more of what everyone saw in that video just now, about our integrated bioenergy power station.
Certainly, thanks, Sajanya. So obviously there's huge potential for bioenergy in Australia. We have such massive resources. And we all know that plants sequester CO2 from the atmosphere using an amazing system called photosynthesis. And we all know that energy can be extracted from that biomass. That's what we've been doing the world over for centuries. We've been burning wood for energy. And from a climate change perspective, I have to say, up until recently, I've never been all that interested in biomass as a solution for climate change, because I've always thought, well, as soon as you burn the biomass, you're releasing the CO2 back into the atmosphere. I guess the key point with what we're looking at here is by the pyrolysis process, rather than the CO2 or the carbon being emitted back into the atmosphere, the carbon is retained as a solid carbon form in the form of biochar, while at the same time we can extract the energy. So the energy, obviously, as an energy company and as patent pending Barton heat engine that we've got, we're looking for that energy to create renewable electricity. But the other thing that's really cool is that we also get the biochar, and the biochar is a fantastic soil enhancer. And by using the biochar in agriculture, we are permanently sequestering that carbon, and that's what I think is so amazing. When we're using waste biomass, and there is a lot of waste biomass around, councils, for example, have got a lot of green waste that they're trying to manage, dispose of. So if we use that biomass, put it through a pyrolysis unit, we can extract energy and create biochar. And the biochar itself has some fantastic soil improvement solutions. So that's why we're interested in it, Sajanya. We think it's really cool.
Yes, I do. So I guess, obviously I mentioned that there are so many different applications for our heat engine. Why was bioenergy our main initial application of the heat engine?
Yeah, well, look, you're right. There are so many applications for a heat engine because there is so much waste heat around. I guess the bioenergy solution for us was of particular interest because it links into the circular economy principles of being able to take the byproduct of another industry and generate electricity and char. And there is just so much biomass available, and councils in particular have a burning need to dispose of their green waste. And when you dispose of green waste in landfills, as the video said, it generates methane. There's a lot of effort going into using green waste for compost, which is fantastic. There's also a range of challenges around that, particularly around contamination levels. And we think that the bioenergy using pyrolysis and producing char is a great complementer to particularly what councils are doing in relation to composting.
Yeah, that's great. So our initial site is at Austeng. Can you walk us through the details about the Austeng bioenergy project? I think specifically, I was really interested about knowing how much waste we plan on processing there, and then maybe just kind of talk a bit about our partners that we're working with.
Yes, certainly. So Austeng is a strategic partner of ours, and right at the moment we are commissioning our Mark II heat engine at Austeng's site in North Geelong. The Austeng Bioenergy project is going to take that heat engine and match it with a pyrolysis unit, and that pyrolysis unit will come from Earth Systems. Earth Systems have extensive experience in building char makers and generating char and also cell char under their Green Man brand. And we're proposing to take 3,000 tonnes per year of overs from Anarchy composting plant. my first question was, what is an over? And basically what happens in the composting process is that those really woody pieces, the big chunks of wood that haven't broken down in the composting process, are actually separated at the end of the composting process, and they're called the overs. And they haven't composted very well at all because they are too woody. This type of biomass is perfect for pyrolysis unit. So we will be taking that from the Anarchy composting plant. We've got an agreement with Geelong City Council to enable us to do that. We're looking at about 3,000 tonnes a year of overs, and we know that most of the composting facilities around the state have this challenge with the particularly woody overs. So that's why it's really complementary with composting process. We will be, like I said, processing 3,000 tonnes a year. We're building our char maker will process 1 tonne an hour of chipped biomass, and then that will be connected to the heat engine. So it's actually remarkably simple. We've got some materials handling kit at the front. We've got the pyrolysis unit. Char comes out one end, heat comes out the other end, and then we drive the heat engine from that heat. And what we get from that is 24/7 renewable electricity. The other thing that I think is great about pyrolysis is that the quality of char you get out depends on the quality of biomass that goes in. And so all biomass, particularly from councils, needs to be decontaminated. But the great thing about a pyrolysis unit is even if there's small or incidental amounts of plastic in the system, that will be pyrolyzed in the system without impacting the air quality, and hence without upsetting the EPA. And so what comes out is clean biochar.
Yeah, that was really interesting for me to understand when I learned that. And I also think it's really neat that our system is complementary to composting.
Yeah.
So I think that's probably really valuable background for everyone watching right now. Can you contextualize for this specific audience, because I assume everyone's here because we're about to launch our investment round on the virtual platform. So for that audience, can you explain what exactly the expected, commercial outcomes for the project are?
Yes, well, Sajanya, it's all very well to be excited about things that we can do with technology, but as we all know, at the end of the day, the dollars have to add up. And again, that's one of the other reasons why we're really quite interested in a bioenergy project, because there are multiple revenue streams, and we can, as we get more experience with running the process, we can optimize each of those revenue streams to optimize the total business case for the project. So a bioenergy plant generates revenue in a range of ways. If we're taking waste such as council or waste where people are having to pay for someone else to take it away, then there's a gate fee to be collected. We can sell the char itself, and there are varying estimates on the value of char. It's going to depend on the quality, how much of it's available, and the demand for char. So I think there's a lot of work to be done with agriculture and horticultural industries to demonstrate or further demonstrate the value of char in their production. We already know it's quite valuable. Then there's the carbon credits from the char, and the carbon credits are generated because the carbon is permanently sequestered in biochar. So when you're putting compost on the land, some of that carbon also remains in the soil, but some of it's more mobile and actually does convert back to CO2, but the carbon in biochar is very stable. And then we've got electricity sales, which can be both behind the meter, which is more valuable than selling into the wholesale market. And one of the nice things about these plants is that they're very compact. So the char maker's compact, the heat engine's compact. So we can put it on small sites, which means you can locate your energy consumption next to a facility that uses electricity, so you can get the benefit of behind the meter revenues. And then finally, there are a range of clever things that people can do with the syngas that comes off a pyrolysis unit. Over time, we'd be looking at wanting to optimize those. There's biodiesel, hydrogen, and even CO2, of which there is commercial demands for CO2. And there's certainly plants that have also built greenhouses next to them, so they can use the waste heat, because there's still some waste heat, and CO2, which is fantastic for optimizing horticulture. So that's the economics. And we've done some financial modelling for various different circumstances. We've looked at most recently a rural council in Victoria, and we showed that biochar or a bioenergy facility was extremely cost effective, even at char prices much lower than what we currently get. With the Austeng plant that we're building, we've already secured an offtake agreement for the char, and which makes it a profitable project from the beginning. So yeah, we're excited not just about how sexy the circular economy story is and the carbon sequestration story and what biochar does for soils, but also for the revenues that we think we can generate, and over time tweak, optimize, and improve the returns from the project.
Yeah. And who knew before either of us started, who knew I'd ever get that excited about biochar, but
yeah. I didn't think I would either, but I am. And while we're talking biochar, the biochar itself is really porous. And so the porosity of the biochar when it's in the soil helps retain moisture, which helps improve the performance of the soils. It also helps retain water, nutrients that are water soluble, because the nutrients are then retained in the soil instead of running off. And it also provides a medium for various bugs and fungi that are helpful in the soil to grow. And please don't ask me any more soil questions, because that's about the extent of my my soil knowledge.
I might have to change the next 10 questions that I had for you then.
Yeah, if you could.
So I think, actually, I have a ton of questions about less project specific questions and more bioenergy pyrolysis, but was there anything else that you wanted to add, about that?
Look, only that, Capricorn Power really want to build a heat engine for every community. And with biomass being such a ubiquitous source of energy, and having compact systems and systems that work at small scale, at community scale, that really is an opportunity. And it's also really nice to think that this bio-waste can be treated quite locally. I'm aware of bio-waste being trucked hundreds of kilometres from its source to other locations. And obviously the transportation costs and the environmental impacts of that transportation's not optimal. So I really think that the compact scale of char makers and the compact scale of the Barton heat engine combined really makes bioenergy viable at small scale in lots of communities, and potentially even in inside the Greater Melbourne. Round the corner, you can have a small bioenergy plant. So I think that's pretty exciting. We've also done a business case for a bioenergy plant that was located next to a sports centre, and the waste heat adds to the economics of that. So you don't need to use gas to heat up your to heat up your swimming pool water. Instead, you've got some waste heat from the bioenergy facility. So yeah, that's my final word before you ask me a whole bunch of hard questions, Sojourner.
Just a few more. So like I said, I just wanted to ask a couple general questions. So what is the difference? I think I wanted to know that. We touched upon composting earlier. What is the difference between compost and char for soils?
Yeah.
That is one soil question.
Yeah, you did ask me another soil question. So look, my understanding is that soil benefits from both compost and char. They provide different benefits. Some of those benefits are overlapping. And again, that's why I think, biochar is so complementary to compost. The carbon in compost is more available and more, I think I think we need both. The char provides improvement to the structure and real water retaining capabilities, and the compost is also hugely valuable. So that the soil needs both. It's not an either or.
Right. I think that whole idea of that we need more solutions rather than like the perfect one. Yeah,
there's no silver bullet. We all know that. Our transition from fossil fuels to one coal-fired power station to a post-carbon future has multiple solutions to it, and that many of them are complementary and supportive and overlap. And that's where the Barton heat engine using waste heat really fits into that story, as does bioenergy plants.
And I think, so I was curious about this, so I think other people would be too. Is pyrolysis less polluting than incineration?
Pyrolysis it retains the carbon. So incineration, you're basically breaking down the biomass in the presence of oxygen, and you get carbon dioxide. With pyrolysis, a good proportion or most of that carbon is retained in the form of solid carbon in the biochar. So you don't get the carbon dioxide going off. Hence, bioenergy plants have got negative carbon sequestration. So we're actually, at the end of it, we've got more carbon in the soil than when we started. So yes, definitely less polluting when it comes to carbon, and when it comes to various other gases that you get from incineration. It depends on the quality of the biochar, the quality of the biomass, for whether you've got incineration or pyrolysis.
Yeah, that was just a question that I had initially, and so I thought other people might have it as well. So is pyrolysis, kind of leading me to the next question, is pyrolysis the best method for bioenergy?
Look, like I said, we need a range of solutions. There is so much organic waste, and it comes in various different forms. And for some of the waste, sewage sludges, for example, there's a whole lot of anaerobic and aerobic digestion that may be more appropriate. So it's not the best, it's just part of the solution. And in some circumstances, I think it will be the best, but complementary to all of the other technologies out there.
Yeah. That makes sense. And, I think when I started the Capricorn Power, I started learning more about this, but how does bioenergy compare with solar and wind energy? And you did touch upon this,
well, look, we all know the success story of PV solar panels, and I think everyone on the call will be so grateful that has been so successful. The price of power on sunny days is extraordinarily low, thanks to our solar and wind energy resources. What the differences between solar and wind energy is that bioenergy plants can be run 24/7. which solar and wind is sometimes, well, we know is more variable and requires firming. So, that's the main difference.
Yeah. And I see a couple of questions coming through about this. So hopefully this will answer it for everyone. Can you use pyrolysis for other forms of waste?
Look, so the answer is yes. And there's a whole industry of various waste to energy plants for all sorts of general waste. And all of these technologies have pluses and minuses. The key thing to know about waste to energy is that modern waste energy plants do not look like the incinerator that some of the older people in the audience, like myself, might remember when we grew up in our back gardens. They all use quite extensive scrubbing technologies, so the air emissions from other wastes are usually good, and if they're not good enough, they won't get EPA approval. So you can. We are Capricorn Power. We are playing in the space of clean biomass. So we're not interested in taking certainly anything toxic and putting it through a basic char maker. There are plenty of other people out there that would be doing that. And the incineration technology is used for general waste. The ash is contaminated, and there is no way you would use that for biochar in agriculture. So we're looking at clean waste, clean biomass.
Yeah,
that's the space we're playing in.
So I think that was the last question for me, but we're getting some questions rolling in, which is great. So, well, you kind of did touch upon this, but so can the device combine the multiple sources, for example, char process with methane / in parentheses human waste? Someone's wondering.
So we are not playing in the space of human waste. That is the remit of water companies and sewage treatment plants. I have no doubt that there are people out there that would be interested in taking sewage sludges and potentially pyrolysizing it, but that's not the space that Capricorn Power are playing in.
Yeah, great. And the next question is, how do you price it? I assume our projects on customers' needs and council systems.
How do we price it? Was that the question?
Yeah.
Yeah. Look, what councils need is a secure outlet for their waste. They need to know that it meets community expectations. Councils, quite rightly, are the closest tier of government to the community and very sensitive to community needs. And they also have budgets that they have to meet, and it's difficult for councils when they get unexpected costs. And councils have very complex businesses to run, and where they get an opportunity to outsource something technical and complicated to someone else, then they usually do, because there's usually specialists out there that can do the job. What Capricorn Power are most interested in doing is owning and operating these plants ourselves and funding them ourselves, and charging council a gate fee to take the waste. The other benefit of structuring a project that way is that governments have to meet the requirements of what used to be called the Trade Practices Act, but I can't remember the name of the new act. And they are not allowed to compete with the private sector to sell product. So for some of those councils, it's awkward to be running, say, a composting plant or a biochar plant and then going out and trying to sell that commercially, because of the competitive neutrality restrictions they've got. And because, again, that's not marketing, and finding new markets and marketing stuff is not core core competency to councils. So we think that the best solution that we can offer councils is for Capricorn Power to own, operate, take all the risk, and charge councils a gate fee. We have to work closely with councils because councils are providing the bio-waste, and we need to make sure that that biomass is clean, so that the quality of the char is not compromised.
Yeah. And next question is, why not get farmers involved as a revenue stream?
Well, we certainly will be. So farmers will be a key driver of biomass demand. We are looking at partnering with the sort of organisers. There's a lot of organisations out there that do extension work with farmers, and we want to work with those groups who work with farmers to do trials of biochar. There's been plenty of trials already done. For those that are interested, there's the Australian and New Zealand Biochar Initiative. If you Google that, you will find the work of that that organisation, and there's a fantastic report there where they have done. They've summarised a whole lot of different case studies and also had a look at the economics, the return for each of those farmers. I think it's fair to say that the business case for biochar for broadacre cereals has not been demonstrated, but for horticulture it absolutely has been, and there's a whole world to explore in terms of the benefits of actually feeding biochar to cattle, in terms of improving the productivity and the health of the animals, as well as reducing their methane emissions, which of course is a great outcome from a climate change perspective as well.
I think there was so there's an edit to the first question about the combining multiple sources. So
yep.
I'll kind of get back to them. So the question is actually based on using more than one source of renewable energy. Can the heat from two renewable energy sources be combined to power a device? For instance, yes. Solar and biomass, or biomass and methane as example.
Yes. So, we've got one of the things we'll be looking at is landfill gas, and a biomass plant can both feed one Barton heat engine, for example. We've got another site where we're looking at the possibility of also adding solar thermal plant. Some energy from that could be funneled in. So at the end of the day, the Barton heat engine doesn't really mind where the heat comes from. So you can combine all sorts of sources of heat together at particular locations to get your renewable energy.
Yeah, great. Hopefully that was a sufficient answer. You can always ask more. So
you can always ask again, yeah.
So are we looking at selling the energy plants directly to customers / waste suppliers, or facilitating the partnerships with waste suppliers and maintaining ownership of the individual plants?
We would be open to either of those options, and the best solution will depend on the requirements of the client.
Yeah.
Yeah, so feel free to contact us. If you send us email us your details or your phone number, we're happy to have a chat to you about which of those would work best for you.
And next question is the Pyrolyzer char maker part of the heat engine package or purchased separately?
So you can purchase it separately. Capricorn Power can provide you an integrated system, or you can integrate it yourself.
Okay. And then we have someone just asking how the Barton heat engine works, like what makes it different?
Oh, goodness. So Rowan Doyle, are you on the call? Are you up to call Rowan in to answer that, Sujanya, or not?
We could. Actually, for that person, we have a pretty technical webinar that we hosted last week, which is actually available on all socials.
Yeah.
And I can email that out again. This is a great discussion with him.
Yeah.
But I think, you know, the main points around the fact that we're container scale and we don't use water.
Yeah. The main thing about the Barton heat engine is it uses a different heat cycle, and from what's already on the market. And after that, the answer is highly mechanical engineering orientated, and I would highly recommend Rowan's very energetic and great description of how the Barton heat engine works. So yeah, definitely have a look at that.
Yeah, and that is available on all our social, LinkedIn, Facebook, Twitter, and on our virtual newsfeed as well. So I think the next question that I have, we might have to wrap up soon, so we might just take one or two more questions. Will the Barton Capricorn Power heat to energy engine be compatible with any pyrolysis unit system in the market here or overseas? And are there any feedstocks it won't take?
So the answer to the first question is yes. And are there any feedstocks that won't take? There'll be plenty we won't take, and that'll be dependent upon the contamination risk and what's in the actual feedstock. So you'd actually have to look at the chemical analysis of that. And just to reiterate, we're really focused at Capricorn Power on clean biomass. You know, we think that green organics is a great option for us, and we recognise that there are some incidental plastics in that, which we think the system will cope with, but we are interested in biomass, clean biomass, and at this stage, certainly at this stage, we're not looking at more complex outputs from various other production units.
Yeah.
Just while we're talking about biomass, for those of you who haven't read Ross Garneau's book, Superpower, it's a fantastic read and it's incredibly optimistic, but there's a whole chapter in here on bioenergy. So if you are interested in bioenergy, I definitely recommend Ross's fantastic book.
We might have to start a Capricorn book club.
Good idea.
So I'll take one last question if that's okay for everyone. And just to let everyone know, if your question wasn't answered, what we usually do, we'll get them and then we'll answer all of them and make them available on our virtual newsfeed for you. So that's coming at you later. But the last question was, when's our next round investment?
Well, you can answer that, Sujanya.
I might take that one. So if you've expressed interest, and you obviously still have time to do so, you can express interest until Monday night, actually. And we urge you to do that, because if you do that, you'll actually hear about when the investment round is live first before everyone else does, which is great. And that'll be, I mean, not giving too much away. It's next week. It's early on next week. So look out for that. And yeah, well, obviously, if you're on a mailing list, etc., you'll get all the details. So make sure that you don't get into your spam folder or anything. And on that note, of course, again, if you haven't expressed interest, please go to our virtual homepage to do so. If you have, thank you. If you support us before, thank you, thank you, thank you. Yeah, we're just really excited because so much is happening right now. But thanks again for taking time on a Tuesday night. And if you have any other questions, you can always email us at info@capricornpower.com.au. And you can, I'll be there to answer it. Any one of us will be able to answer that, technical or otherwise. And thanks so much. And I think.
Thank you very much, Sujanya. Thanks very much, everyone, for listening and for sharing our enthusiasm for what we're doing with bioenergy at Capricorn Power. So thank you very much.
Yeah. Thanks, everyone. Have a great night.